Now, that was the concept phase, right? So it's taking the voice of the customer into some measurable requirements and trying to kind of get that into our design phase. So now we're in our design phase. In our design phase, like I said before, some things we're going to focus on and maybe some new tools to learn are house of quality as well as FMEA. So let's take a little bit of time and look at how we're going to take our design requirements from our voice of the customer and create what's called a house of quality. Now, I'll show you the house of quality close up in a minute, but this is overall what a house of quality looks like. It's a very, very full matrix kind of view. But the reason why we do this is the house of quality aligns what the customer said, so in our concept phase, with the actual design parameters that we can work with. So our goal with this then is, first of all, we're going to improve customer satisfaction because we're making sure that we're designing products or processes that align with what the customer wants. That's really, really important. And then we're going to enhance our product development by reducing risks and rework, because the last thing we want to do is spend millions of dollars creating something that go to the customer as maybe just a beta test or a test market, and they reject it, right? So we're going to reduce that risk by making sure the voice of the customer is tied into the design to begin with. We're going to promote better resource allocation through prioritizing. So that's the other big part of design for Six Sigma, is really prioritizing customer requirements. We might not be able to hit them all. Let's make sure we get the top priorities. And then we're also making sure this is communicated, because one of the complexities with designing processes or products is it usually involves many, many teams. In the product manufacturing, for example, we've got the marketing team, maybe the market research team, then going to some sort of group of design team, a testing quality team, and then a manufacturing team, and then back out to the customer, right? There's a lot of collaboration that has to happen. So the goal with the house of quality is to really make sure that that collaboration happens, everything's well documented, and tied back to you, the customer. So looking at more detail, there are actually 3 houses of quality. We're going to focus on house of quality 1. Now, you should recognize what you see down here. Again, this has been automatically populated. These were the specific measurable requirements that came in from the customer. We saw these when we did the voice of the customer summary, as well as when we kind of prioritized them. Based on the priorities we got when we did the pairwise comparison matrix, we can rate them in terms of their importance. And then what we do is we set out to create design parameter or performance criteria in terms of our design, right? So we're going to look at material strength, thermal conductivity, meaning if we want to keep something hot, we don't want it to transfer heat elsewhere. Leak decay. If you think about these tumblers, what these tumblers have are 2 metal walls. There's an internal or an inside system, and then there's an air gap, and then the outside wall of a tumbler. What we want to make sure is that air gap doesn't leak, because if the air gap leaks, that means the heat retention is not going to be as good. So that's going to be a very critical metric for us. So we can look at all these metrics that we're kind of creating parameters around. How thick do the walls need to be? What kind of material? If you remember from the initial problem, we're looking at maybe testing a new blend of steel for this to help with our heat retention. So as you see this, each of these things is a 9, 1, or a 3. We're relating these performance criteria to these specific voice of the customer criteria. So we're saying, okay, material strength gets a 9 when it talks about the tumbler does not dent when dropped from 5 feet. That has a lot to do with material strength, right? It may have a little less to do with the capacity of the tumbler. So we're tying these performance criteria in terms of how we're designing the product to the actual criteria that came in from the customer and which ones relate to which. What that will help us do is, first of all, we can compare how we're doing to our competitors. It will also help us decide which ones are really the most important. And so here we have the most important ended up being related to the material type. it's a little hard to see because these tie together when they're on the same page. You don't necessarily see it on different pages, but we see which are our most important performance criteria that we really want to focus on. And we're starting to create specifications, right? So we need to make sure the wall thickness, for example, is between 0.7 and 0.5. Our most important thing had to do with looking at the type or the chemical mixture of our steel. And then finally, we can look at how these things relate to each other. So we've identified these specific criteria we're going to look at, and material strength, for example, is very related to thermal conductivity. It's also very related to wall thickness and material type. It's a little less related to things like the roughness of the surface. So we're just looking at how these interact so we can kind of think about, if we improve one, is it going to make the other worse? And which of these things interact with each other? So that's a quick tour of a house of quality, probably a new tool to many of you, but very key in looking at design for Six Sigma. So hopefully you found that a little interesting. It turns out we're going to do 3 of these. We're not going to look at all 3 in detail, but in our design phase of CDOV, there are 3 house of quality matrices. One, the one we just did, relates the customer requirements to what that means in terms of performance criteria. Our house of quality 2 then is going to take those criteria and relate them to some specific design parameters. So we're going to design this in a specific way so that we meet the performance criteria. And then the house of quality 3 is when we go from design to manufacturing, right? So we've designed this process. Now we want those design parameters become process parameters. In other ways, once we've designed and optimized this product, we're going to translate it over into what that means when we manufacture it. So these are all linking everything, most importantly, back to the voice of the customer. Now, the other big tool in the design phase of CDOB is FMEA. FMEAs are used all over the place, not just in design for Six Sigma. They're used in healthcare. So if you're looking at something like what causes patient falls, we might actually list out all the possible reasons why a patient might fall in a hospital, and then look at how severe the consequences are for that type of fall, how often it occurs, and how easy it is to detect. That's what an FMEA does. We list out every possible thing that could go wrong. That's why it's considered a brainstorming tool, because we're actually thinking about everything that can go wrong. Here we're thinking about everything that could go wrong in our tumbler. So those are our potential failure modes. We look at what that causes. So if I have a dent or a crack in my tumbler body, right, that means it's going to be less durable. It also means it's unable to maintain the temperature. We look at how severe that defect is, and we rate that on a scale of 1 to 10. We can also set colors here so that the red are the worst in terms of the worst kind of defect you could see. That's the severity. We look at what could cause that. So dents or cracks could be material defects. It could be that I dropped it. There's different types of material defects. I've kind of delineated these. We have problems in the tumbler vacuum or the insulation, right? So that leak decay parameter we were talking about, that means we've got poor thermal insulation and the effect would be unable to maintain temperature. That could be caused by a material defect. It could be caused by a vacuum seal didn't seal correctly, a vacuum seal defect, right, etc. With each of these potential defects, we look at how often they occur, and we rate that on a 1 to 10 scale. We look at how we're kind of trying to control for that to make sure it doesn't happen. And then this one's kind of interesting. How easy is it to detect that type of defect? This becomes important because some defects are very hard to detect, which makes them kind of raises their criticality, right? Because we might not know about them until they get out to the customer. Whereas other things like a scratch on the surface is going to be much more detectable before it goes to the customer. So the detect score is a little less. All of that leads to this RPN. RPN is a risk priority number. And anything red, these are our highest risk defects that we want to really focus on. The things in green, we might still worry about them because they're severe, but they're either easy to detect or they don't occur that often. Things in yellow are kind of in between, but this is a nice way to prioritize and also think about every possible thing that could go wrong, prioritize them in terms of the things that are the highest risk to your organization, and make sure you're addressing the highest priority things and on down to maybe the lower priority things. So it doesn't mean you can't address all of them, but you're going to really order them in terms of the risk they create for your organization. And that risk is based on how severe it is, how often it occurs, and how easy it is to detect. So if you haven't used FMEAs, they are great. Again, you can use them in all kinds of processes, including things like service quality, healthcare. In this case, we're using it as we design our tumbler, but very useful way to really keep defects from happening by actually thinking about which ones could possibly occur and building in protections for that. So I highly encourage you to explore FMEAs if you haven't already.